Third technique in solving linear systems is called linear combinations or elimination. And just as the word elimination means, you're going to eliminate one of the variables, x or y, to solve for x or to solve for y. And then once you have x, you're still going to use substitution. You're going to substitute back in to one of the equations to find the other variable. So in the first thing, it says using addition first. So you're going to look to try to eliminate by using addition subtraction. If you look at the problem that we have, you see that you have a negative x and a positive y in both equations. So what we're going to do is we're going to add them together. Okay, we're going to add these together. All right. All right, so we're going to add. All right, right here, we're going to add these together. And what we're going to get is negative x plus a positive x is just 0x. Here we're going to get 8y is equal to a negative 8. When we divide by 8 on both sides, we get y is equal to a negative 1. So that's one way of setting it up. This problem was already set up for us where a variable can be canceled out. We're going to try to eliminate a variable. Now, once you have your first variable, all right, we got y is equal to a negative 1, we can pick either one of these equations to put y back into. And again, you want to choose the better equation. I'm going to choose the second equation, and we're going to say that x plus 6 times a negative 1, so we're going to substitute that negative 1 in for y, is equal to a negative 16. So we have x minus 6 is equal to a negative 16. When we add 6 to both sides, we get x is equal to a negative 10. So the solution is negative 10, okay, negative 1. Now let's check to see if those work. In the first equation, I'd have the opposite of a negative 10, so it would be 10, all right, plus negative 1 times 2, which would get me a negative 2. Does that equal 8? And the answer is yes. All right, now in my second equation, all right, I would have a negative 10 plus a negative 6, because 6 times a negative 1 would get me a negative 6. Does that equal a negative 16? And the answer is yes. So our solution, negative 10, negative 1, is correct. Second example of solving linear systems by elimination, we're going to use multiplication first. And in this case, again, you're trying to eliminate one of the variables. You're either going to try to eliminate x or you're going to eliminate y. And the problem we have here, both x's are positive. So if I wanted to eliminate x, I'd have to multiply one by a positive and one by a negative. All right. If I try to eliminate y, you can see that there's a positive 8 and there is a negative 4. So I'm going to eliminate y in this case because now I only have to multiply one equation, and that's the first equation by a 2, which will eliminate y. So in this case, we're going to use multiplication first. All right, I'm going to multiply the first equation, all right, by 2. I have to multiply the whole thing by 2. So here's what we get. We end up with 10x, right, minus 8y, and that's what I want because I want to eliminate y, and it's a positive y in the second equation, is equal to 6. The second equation stays the same. Okay. And now, just like we did in the first example, we're going to add these two equations together. So we take these equations and we're going to add them together. So we end up with 12x. We end up with 0y is equal to 4. When I divide by 12, my x value is going to be 1/3. Now, again, I can take this 1/3 and I can substitute it back into either one of my equations. So we'll take it and let's go with let's try it with the first equation, second equation. I say let's take 2, all right, times 1/3 times 1/3, all right, plus 8y is equal to a negative 2. So I have 2/3, all right, plus 8y, all right, is equal to a negative 2. Now I'm going to be taking a negative 2/3 to both sides, negative 2/3 to both sides, and we end up with 8y, all right, is equal to, all right, a negative 2 2/3, but I'm going to write that as a negative 8/3. Right? So I'm going to write this as a negative 8/3. Okay? Now, I have to divide both sides by 8. Okay? I'm going to divide both sides by 8. Okay? Again, now I have a fraction, so if I'm dividing by 8, I'm actually going to multiply by the reciprocal. So the reciprocal of 8 is 1/8. So I multiply this by 1/8. My 8's will cancel, and my y value is going to be equal to a negative 1/3. So let's check to see if these work. I have a positive 1/3 and a negative 1/3. So we have 2 times 1/3, which is going to get me 2/3. All right, 2/3. All right, plus 8 times a negative 1/3, which is going to get me a negative 8/3. All right, does that equal a negative 2? And in this case, you have you have 8 minus 2, which would give you negative 6/3, and that is true. Now let's go up here and check this first equation. I'm going to have 5 times 1/3, which is going to get me 5/3. Oops, get me 5/3 minus 4 times a negative 1/3, which is going to get me a positive, all right, 4/3, all right, is equal to 3. And is that true? 5 plus 4 is 9. 9 divided by 3 is 3. So our solution to this equation is 1/3 for x, right, and a negative 1/3 for y. Of elimination, solving linear systems by elimination, we're going to have to arrange like terms. And what I mean by that is we're going to line up our values. You see our x's are lined up, but our y's are on opposite side of the equal sign. So in the first equation, I'm going to need to rewrite it. All right, and so the first equation, which is 3x, all right, equals negative 6y plus 12. I'm going to have to add 6y to both sides. So I'm going to add 6y to both sides. And so what we end up with here is we end up with 3x, right, plus 6y, right, is equal to 12. I'm going to take the second equation and write it right below it. Negative x, right, plus 3y is equal to 6. Now again, we need to eliminate one of the variables. The y's are both positive, so I'm going to choose to do x this time. Now sometimes you might have to multiply both equations. We haven't done an example like that, but in this case, again, we don't have to do that. We can multiply this second equation by 3. And when we do that, we end up with the top equation is going to stay the same. The bottom equation ends up being a negative 3x, so we're going to eliminate x, right, plus 9y is equal to 18. Now again, we're going to take these two equations and we're going to add them together. The x's cancel out. We end up with 15y is equal to 30. When we divide by 15 on both sides, we end up with y being 2. All right, so my y value is 2. Now I can go back into either one of these equations and figure out what x is. And so we'll do that for, let's do the first equation where we got 3x, right, is equal to a negative 6 times 2, right, plus 12. So I end up with 3x is equal to 0 because I have a negative 12 and I have a positive 12. So therefore x is going to be 0.